So in this video I will be discussing Codeforces round 968 rated for division 2. So I will be solving first 4 problems of this set. So I will be starting with problem number A, that is turtle and good strings. So in this question we will be given a string S and it is considered to be good if and only if there exist T other strings such that T1 T2 plus Tk is equal to S. Okay, and there is one more condition, that for each and every string in this particular sequence, let none of the first character of any string should be equal to the last character of any other string, such that I is smaller than j. Okay, and this should be true for each and every I and j. Okay, so if you think carefully, like how, when is the string good, so we can simply try to break down that it that in the last part of the string there will be this part of the string, right? In the last string there will be this part of the string, and in the first part, in the first sequence of the string itself, there must be the a must be the first character of the string, and then the last, and in the th string the c must be the last character of that particular string. So if these two are, if we consider only these two, if we consider only first and the last string in the sequence, then we can notice that first character of this string must not be equal to last character. Okay, which simply means that of the given string the first character should not be equal to the last character. If this condition is true, then the answer is yes, else answer is no, because in each and every other case you cannot make a string. Okay, because the reason is simple. In the first string the first character will be there, and in the last string the last character will be there, and if they are equal, then there is a one possible I and j pair such that the first character of a string is equal to last character of that string. Okay, so if they are not equal, the answer is yes, else answer is no. So this is the only explanation of this problem A. Let's now discuss B problem, that is turtle and piggy are playing a game too. Okay, so basically in this question we will be given a integer array A of n size. Okay, and the turtle and the piggy are playing a game such that turtle goes first and the piggy goes second, and they will play alternatively. Okay, and in a single operation what they can do. Okay, if the length of string is 1, then the game ends. Okay, but if the turn is of turtle, then what we can do, then what turtle can do, turtle can simply choose an integer I such that I is smaller than m minus 1 and set a of I to maximum of a of I comma a of I plus 1, and remove a of I plus 1. Okay, which means he will be choosing an index I and setting that index to maximum of index I comma index I plus 1 and removing index I plus 1. Okay, and similarly the piggy's son, what he can do, he can simply set the number to the minimum of a of I comma a of I plus 1 and remove a of I plus 1. Okay, now turtle wants to maximize the value of a of I in the end, because in the end only one number will be remaining. Okay, and the piggy wants to minimize the value of a of 1, the last remaining number, and we have to find that last remaining number, what is the value of that remaining number. Okay, so if they both play optimally, what is the value of that last remaining number. Okay, so how we can solve this problem? So if we look the problem carefully, for example, let me take this example. Okay, so let me take a, so for example, this is a stream of number given to you. Okay, uh, okay, now what we can do, I will simply write this string in the sorted order. Okay, so 2 2 2, okay, 1 2. Okay, then now I think so next is 5. How many 2 5s are there? Okay, now I think so it is 7 7 7 7. Okay, 7 7 9 and 10. I think so I've missed number, so number 10 10 9 7 9, there were two nines. Okay, 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9. Okay, which number is remaining? I think so. Okay, there are two tens. Okay, done. So in what turtle want? Turtle want to maximize the number. Yes. And what piggy wants? Penny wants to minimize the number. Okay. So this is a maximize and this is minimize. Okay. So to maximize a number, what turtle can do? Turtle can simply wants Turtle will simply wants to make the last number among the second part of the array, which means the turtle wants to make the last number of the array among these number only, right? Because these are the maximum numbers. And what Piggy wants? Piggy wants to make the number among the minimum available numbers. Okay, great. So let's start with turtle's turn. Okay, turtle want? Turtle want the maximized number. Okay, so he want to safeguard the maximum number possible. Okay, done. So first operation, he will choose this operation from the maximum and remove the 10, and the only remaining number would be 10. Okay, done. Now next, what Piggy wants? Piggy wants to minimize the number. So what Piggy will simply do? Okay, so Piggy wants to demolish the maximum possible numbers. Okay, done. So he will simply try to dominate among these number only, because yes, and remove these numbers. And similarly, what turtle wants to save this number and remove these numbers. Okay, so among this war, you tell me which number would be remaining if both of them play out optimally. So I guess the middle number will always dominate, because if they both play optimally, the only middle number would be that number which would be remaining at the end. Okay, so turtle will remove all of the minimum numbers. Okay, so if he wants, like, he will choose these two numbers. Okay, and make these two is equal to 5 and remove the 5. So simply 2 will be removed. Okay, but Piggy what? Piggy will remove the last number. Okay, Piggy will remove the last number. Then again, what turtle will do? Turtle will remove the smallest number, that is again 2. What Piggy will do? Piggy will remove the largest number, that is 10. Simply title this and this, and add, then 7 will be remaining. Okay, and there's a catch, like if the length of the array is odd. For example, the given array to you is 3 3 4 7 7. So in this case, uh, the middle element will be answer. And if the length of array is even, okay, for example, this is 7 9, and this is 10, and for example, this is 15. So in this case, the answer would be a middle plus 1, because the turtle will play first, and if he is playing first, he is having a dominant hand. Okay, so the upper one would be answer. But if my pig is playing first, then this would be the answer. But in this case, turtle is playing, so the answer is mid plus 1 in the case of even, and mid in case of odd. Okay, so this is the explanation of problem B. Let's now discuss problem C, that is turtle and good pairs. So if you read the question properly, you will eliminate many of the conditions which are given in this question only. Okay, so let me tell you how. So, okay, so in this question you will be given a string s, okay, string s, and what you can do, and there's a pleasant pair. Okay, there is a pleasant pair, and what is the definition of pleasant pair? A pleasant pair is that pair such that uh, your I is smaller than j, and there exists a k which can be equal to I. Okay, great. Now what is the condition? Condition is that your s of k should not be equal to s of k plus 1, and your s of k should not be equal to s of I, or your s of k plus 1 should not be equal to s of j. Okay, so let me take the condition, like for example, a b c. Okay, so if you are choosing I and j are this. For example, your I is this and your j is this. Okay, and your k is, for example, I only. Okay, this is your k, because you know one thing, I and k can be equal. Okay, done. This is your I and this is your j. So tell me, is this a pleasant pair? Let me check the condition. My s of k is not equal to s of k plus 1. Yes, my a is not equal to b. So first condition true. Is my second condition true? Either one of these conditions should be true. So tell me, your s of k is not equal to s of I. Uh, yes, my s of k is equal to s of I. So the first condition is not true. So let me try with the second condition. My s of k plus 1 is not equal to s of j. My s of k plus 1 is equal to s of j. So second condition is also not true, which means the condition given to you is not true. Okay, so the actual condition is actually simply I and k should be greater than k and j should be greater than k. So this is the first of all condition given to you, not this one, because in this case they are given an equal case. So eliminate this condition, and this is will the final condition. Okay, done. Now let's see what is saying now. So besides this, a turtle consider a pair of I of j to be good pair if and only if the s of I is equal to s of j, or s of I or I or j is a pleasant pair. Okay, so the pleasant pair is this pair I told you earlier, and s of I is equal to s of j. Okay, which means your I is should be equal to s of j. Done. So that is a pleasant pair. So turtle wants to reorder the string such that the number of good pairs is maximized. Okay, so how to solve this problem? So you may notice one thing, that this condition is again not necessary. But why? Because at then the number of pairs, the number of equal pairs in the array should be same only. For example, if this is the array given to me, if this is the string given to me, cb, so your your I and j pair in which your a of I, if in which your s of I should is equal to s of j, would be same at the end only, because in this case you can see one, this pair and this pair, and this pair and this pair. So total three pairs are there in which your I, in which your this condition is satisfying. Okay, now if you rearrange this string, your this three would be same only, this would not be changed. Okay, which means this condition is again not true. Okay, this condition is again not necessary to solve this problem. So the only condition left is that your I, you have to choose two strings, two integer numbers I and j, such that k can occur between I and j, and your s of k should not be equal to s of k plus 1. Your s of k should not be equal to s of k plus 1. Okay, so what does this signifies? Which means you have to minimize this such, you have to maximize such pairs, or in the, or if you are minimizing these pairs, on the other hand you want to justify that your s, you have to if you want to maximize this pair, then it simply means you have to minimize these pairs. Okay, okay, s of k plus 1. Okay, so in short what problem is asking you to, given a string s, and you have to minimize the number of pairs such that your s of your adjacent, you have to minimize the number of adjacent same pairs. Okay, so for example, I hope so the problem statement is clear to you. So let me repeat it again one more time. Like, given a string s, you want to minimize the number of adjacent same pairs by rearranging the string. So this is the question which is asking you to do. So how to solve this problem? So there can be multiple ways to solve this problem. So let me tell you how I solve this problem. So let first of all take this example. For example, this is an example given to me, D, 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 D and F. Okay, so you can see there are two pairs which are same. So I have to minimize the operation. So what I can do, I can simply put E and F between D's. Okay, D, F and D. Okay, this is correct. Yes. So so you can see none of the adjacent pairs are same. So the answer is this in this case. So but how to optimize, like how to get the best possible string? So I will tell you my way how I solve this problem. So uh, so first of all, what I did, I find the frequencies of all the numbers. Okay, for example, let me take example. mm, uh, for example, m is coming 7 times in my strings. Okay, and let it be, okay, 7 only, 7 times in my string. My p is coming 4 times in my string, and my, let's suppose, and z is coming 2 times. Okay, they're same, pretty much same. For example, my I is coming 2 times in my string, and my b is coming only 1 time in the string. So if this is the sequence given to you, how would you approach the problem? So I will tell you how would you approach the problem. So first of all, take the maximum occurring number. Okay, okay, take the maximum occurring number. Then uh, write the number, that number times. Okay, m m, write the m 7 number times, 7 number of times, 1 2 3 4 5 6 and 7. Okay, done. So remove it from the queue. So this is basically priority queue only. Just remove this from the priority queue. Now come on the second number, that is p. Your p is coming 4 times. Now you have written m 7 times. Just add p in front of m. Okay, p, let me take white color only. P, P, P and P. Okay, done. Done. Now remove this P from the priority queue again. Now next number is I, which is occurring 2 times. Okay, done. Okay, done. So what I will do, I will simply write I, okay, from at this place. Okay, at this place. Okay. So for example, my B is also coming 2 times in this case. I am for the sake of example. Okay, done. Now this is already removed from the priority queue, and let's suppose my A is also coming 2 times. Now what I will do? So now B is here. How do I arrange B? Now I am at this string. Just add B here. Now you can see there is no more M left. Just start from the first string itself. One B you have added. Again add B in front of this first string. Okay, B added. Now you are at A. Again add A at this string. Again add A at this string. So hope so you got the pattern. The number of strings you will get, just append it in the first possible sequence. And what is the first possible sequence? This is the occurrence of maximum occurring character in your array. Okay, now what is my final string? My final string is simply, maybe you have noticed, my final string would be mpb. Write it first time. Okay, let me change the color. My final string would be mpb. Okay, mpa. Okay, mpa, and write it the in this is manner: mp, mi, mi, and mb. Okay, this is the first time, second time, third, four, 5, 6, 7. In this sequence, just append these each individual string in the final string, and this will be your final answer. Hope so you got the point what I am trying to say. So if you have any doubts, you can please comment below, and you will get the code. Okay, I will show the code also. So this is a code for B. I think it was easy, just a middle index only. The second code. Okay, first of all, make a map and store frequency of each and every character. Okay, make a priority queue. Okay, just push its occurrence and the character in the priority queue. Okay, done. Now make a vector of strings such that you will add your maximum occurrence. You will such that each and every string in this vector of string would be your maximum occurring character only. You can see nums is the frequency of that maximum occurring character, and I'm just pushing back the each and every character as a string in my vector of string. Okay, done. Now while my priority is not empty, just find the character and its occurrence. Okay, done. While there is occurrence of that character, just add that character in that in the index occurrence of my file in this string. Okay, what I'm trying to say is this only, like p. Okay, done. You can notice I'm just making index plus and modulus a dot size, because if I'm at this size, this point, I will again start from the starting point. Okay, now add this character in the final string, and just do this operation repetitively till your priority is not empty. And after that, for each and every string in your for each and every string in your this vector, just add in front of each other and find the answer. Hope so this is clear to you. Okay, so let's now discuss the problem body, that is turtle and the max problem easy version. Okay, so how to solve this problem? So let me first of all tell you what question is asking you to do. Okay, so okay, you will be given an integer array. Okay, for example, the integer array given to me is 1, 2, 2, 3, 4, and 5. Okay, done. And you will be also be given a integer x. Okay, done. And what you can do, you can perform any number of operation using this x on this operation. And what is that operation? Operation is simply set x to max of x comma that array. Okay, done. So you tell me what is the final value of x after this operation. I think the final value of x. Oh, okay, so let initial x be 0 only. If my initial x is 0, then find the value of x after this operation. I think the value of x would be 2. Okay, because uh, I think hope so you know the definition of x. So according to that definition, my x would be 2. Okay, so if I try to perform another operation, on this x only. So my final x would be max of 2 comma array. Now tell me what is the value of x. So the value of x would be 6 now. Okay, done. So tell me, can you increase your x further? I think so. No, this is the maximum value of x possible. So that is what asking you to do. Just find the maximum value of x. Okay. Okay, done. So this is the maximum value of x which is attainable by performing some number of operation on this array. And okay, done. So hope so this is clear to you. So but this is not the problem. I think so. I will tell you the real problem. So you will be given some number of arrays, couple number of arrays. Okay, done. For example, you are given these arrays and an integer x which is equal to something, let's suppose some number integer 1. Okay, let me take a number only. X is equal to 5. Now you can perform this. You can perform this operation. This operation on any array, on any of these arrays. Okay, on any of these arrays given to you. Okay, now by performing this max operation on any of these arrays, tell the final value of x. Tell the final value of x which you can get. Okay, so okay, done. Okay, done. Like for example, the final value of that x is the final value of that x. Let's suppose it will be something like max of a. I'm taking it max x. Okay, that is max of x. So this is the one operation, but this is not again the question. The question is, now I will tell you the real question. The question is simply, you can perform this operation in a stream of 0 to m. Okay, and 0 to m, your x can be any your. First of all, make a operation with x is equal to 0, then make a operation with x is equal to 1, then make a operation with x is equal to 2, till make a operation x is equal to m. Now you will be getting the some maximum value of x by using x is equal to 0, then 1, then 2. Okay, yes. Now sum all of them up and you have to find that number. What is that final value of sum of all of the maximum x possible by taking initial x as 0, 1, 2 till m. Okay, so hope so the problem is clear to you now. But how to solve this problem? I will now break down the problem in smaller parts so that you can easily understand it. So let's suppose you are given a x as, okay, let me take a first of all array. I'm given an array like 0, 1, 3, 4, 5, 6. I'm skipping 7 and 8. Okay, done. And okay, done. Now another array would be, let's suppose 0, now 4 and 5. Okay, done. Next array would be 2 and 3, then 4, then 8. Okay, done. Now the given x to you is, for example, the given x to you is, for example, mm, let it be 3. Okay, now you will, now tell me what is the final operation you can get by performing that max operation on any of this array in any sequence. So let me tell you one thing, you will only get the maximum max only from one array. You don't need the another arrays. So for example, in this case, if you perform operation of that max, if you perform that max operation on this first array, you will get the maximum max possible. But why? Let me tell you why. By first operation, by first operation uh, okay, by first operation your x would become, I think so, 2. Okay, yes, by first operation my x would become 2. Okay, done. Now tell me, after the second operation, what would your x would become? After my second operation, my x will become, now you know what, now you know one thing, your x is equal to 2, so 2 will not be max anymore. So 1, 0, 1, 2, 3, 4, 5, 6, 7. So my answer is 7. Okay, so the maximum x I can get by performing that max operation is x is equal to 7. Okay, done. Now I will tell you one more thing, that for each and every x which is smaller than or equal to 7, the maximum value you can get is 7 only. Okay, let me prove it with some another example. Let, for example, you're taking max is equal to 0. Now taking x is equal to 0. By taking x is equal to 0 and performing operation on this array, you will get uh, you will get your x as 2. Yes, I will get my x as 2. Now simply performing another operation of with x is equal to on this operation only, you will get your x is equal to 7. Yes, I will get x is equal to 7. So this is the maximum possible x we can get. Okay, okay, done, done. So what is this? So if I ask you what is this 7, but if I ask you what is this 7, this 7 is simply second number which is not occurring in this array. So the second number which is not so tell me what is the first number which is not occurring in this array? That is 2. Yes. Second number is 7. Okay, done. Similarly, tell me for this. The first number which is not occurring is 1. Second number is 2. The first number which is not occurring is 0. And second number that is not occurring is 1. So among all of the second numbers, what is the maximum? The maximum is 7. Okay, the maximum is 7. So now if the maximum second max is coming from this array, which means you will always perform operation which are smaller than or equal to 7 from this array only. Okay, which means for each and every given x from 0 to 7, the maximum x which you can get by taking initial x as 0 to 7 would be 7 only. Okay, done. Now what will happen if I'm choosing x greater than or equal to greater than 7? For example, if my x is greater than 7, now tell me what is the answer possible? I think so answer possible is x only. Now tell me, mm, if I'm taking x is equal to 10, then find the maximum possible x which you can get after performing some of the operation in this arrays. So if you perform any of the operation, your x will decrease. Yes. But if you perform none of the operation, your x will remain 10 only. And this is the maximum value of x which you can get. Which means for any value which is greater than the second max from every occurrence of the array, in that case you will not perform any operation and just your x will be remaining that number only. Okay. So let me now generalize the solution. Hope you got the point. For example, the m given to me is 10. Okay, which means first of all I will perform operation on 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and at then last 10. Okay, now for each and every number from 0 till 7. Now how is the 7 coming? 7 is coming, the second 7 is coming the maximum second max of the array. The maximum second max among this array is 7 only, which means for each and every number which is smaller than 7, the answer would be 7 for each and every this number. And for rest of the number, the maximum number would be that number only. So the final answer would be 7 plus 8 plus 9 plus 10. Okay. So I think so you can calculate this. So okay, I have to multiply this 7 with 8 also because the 8 occurrences are there. 8 into 7 plus 8 plus 9 plus 10. So this will be a final answer. Okay. Hope so this is clear to you. I think so. This was a very much I think so constructive problem I could say, or I can say observatory problem, whatever you can say. So let me show the code also. The code was easy. So first of all, I'm taking a variable name second max. Okay, done. Now for each and every array given to me, I will find the second number which is not occurring in the array. Okay, you can see the variable count. Okay, the second number which is not occurring in the array. Okay, after finding that second number which is not occurring in the array, I will store that second max as a variable name second max. Okay, done. If my given m, for example, if the maximum second max is 7 and m given to me is 3 only, if m given to me is 3 only, this is m and this is second max. Let it second max. If my second max is 7 and my m is only 3, then in that case your answer is simply uh, 3 plus 1 into 7, because the number x would be 0, 1. Okay, 0, 1, 2, 3, and for each and every this number you will multiply that number with 7. Okay, and you can see the answer, m plus 1 into second max. Okay, done. But for the another case, uh, mm, in that case your m is equal to, let's suppose I'm taking 10 again. If my if my m is 10 and my second max is 7, So what is the answer in this case? So the answer is simple. Like for each and every number till 0 to 7, your answer is 7 only. Yes, I will store that number. You can see I will store second max into second max plus 1, because you know one thing, that your second max would be that one number only. So will, because you know one thing, that for each and every number till 0 to 7, your answer is 7 only. So simply multiply 7 into 7 plus 1, because total 8 number would be there for which max is 7. Now for each and every rest of the numbers, for each and every rest of the numbers, which means you will simply add that number only, because for 8 plus 9 plus 10, okay, yes, this is the number. So what is this? You can simply use that formula for finding sum of n numbers, that is n into n plus 1 uh, divided by 2. So in this case your n is m, n is m, in this case for example your this will be 10 only, so you can say m into m plus 1 divided by 2. So in this, what you will do, you will do 10 into 10 plus 1 divided by 2, but this will give you the sum till 0 to 10. You want to also exclude the sum till 0 to 7. Okay, so you will simply subtract the second max, because second max is 7 only. So simply subtract the second max into second max plus 1 divided by 2 from this equation, and you will get the sum of these remaining numbers. Just sum them up and you will get the final answer. So this is a whole story of the problem, buddy. Hope so you got it. I will give the code in the comment section. So if you have any doubts, please comment down, and please like, share and comment on the video. And if you have any doubts, please ask me in the comments. Thank you. Stay tuned for the next one.